Hello, my name is Dimitri and I built FinQuery, which is a UK banking product financial assistant. The motivation for this project was quite simple. I wanted to create something that's both useful for myself and for others. And the idea for it is checking the latest banking products manually can be quite time consuming, and writing a query to AI is much faster and simpler instead of searching comparison sites and manually searching for banking products yourself. So yeah, and another motivation is just I wanted to learn what ArangoDB actually is. It was something new. I wanted to improve my skills, so I thought, why not? For this project, I created a dummy dataset using the Python Faker library. It includes think banking data, like the products and services that they offer. And the reason I had to create a fake dummy data is that I couldn't really find a real dataset that fits my problem space. But ideally, it should be based on real banking data like those used in comparison sites. However, the main problem I'm solving is how people find financial products instead of scrolling through multiple websites. You can just ask AI, that's the idea, right? So I thought it's okay to generate a dummy dataset in this case. The way it works is just, you can see the list of banks, UK banks, the possible rewards, and then the interest rates are randomly generated here. And here's what the actual dataset looks like. Up there I just dropped an irrelevant column. Yeah, so we have the product type, which is what the product is offered by a certain bank. It's the bank here. Interest rate, rewards, loan amount where it's applicable, and the type of account. That's the idea. After generating the dataset, I then converted it into a graph format, so network X. And the way it works is in the model, the banks are the nodes, the products are linked as connected nodes, and additional relationships, stuff like interest rates, fees, or features form the edges. After that, I then loaded it all into ArangoDB, as you can see it here. I set up the ArangoDB locally, so that's why I can expose all of this information without worrying. And yeah, so let me actually explain to you how the AI dynamically processes user queries. First of all, this is the payload that we receive from the front end. We receive the user query, the API key, the history of messages, and the chat ID. Now, chat ID was necessary because I had a feature. Unfortunately, it doesn't really work properly, which is why it's commented out. But the idea of the feature was to find any similarities between previous conversations in the history using call sign similarity. But as I said, it's not working properly, which is why it's commented out. So instead, we pass in the entire history, and we can get away with this because agent 3, which is the last agent, summarizes the entire response, and therefore the response is very concise, and the user inputs are also quite concise as well, which is why we can get away with this, like I said. Now, agent 1, what agent 1 does is it takes the query, it takes the history, and it tries to generate a concise AQL query for agent 2 to then execute and maybe improve. So it gives an idea to the next agent of what what the AQL query should have. The way it does it is it has a database schema and is given certain instructions to generate a little base for the AQL query. Now, agent 2, on the other hand, then also generates the AQL query, also generates the AQL query, but a bit better, so it doesn't include any additional text, so we can just pass this entire query straight into the query execution part in ArangoDB. Now, agent 2 support agent, this is just there just in case there is a certain number of, let's say an error occurs when you generate an AQL query and executes it. So agent 2 takes the error and improves the query, and it does it 3 times. So it does. I don't want to run into an infinite loop, which is why I've limited to 3 attempts only. Lastly, agent 3 takes the entire history of the chat, takes the data retrieved from the AQL query and the user query, and it summarizes the entire result and retrieves it, returns it back to the front end for the user to see. Now let's test out a couple of real queries. So to start off with, you would need to go over here and get the grok key. Then I've already done that. So when you save the grok key, you get a little message. Now let's start with a new query. I've got this sample query that we can test. So what it says is essentially, it says I have £10,000 to save. I'm considering ISAs and stocks and shares ISAs based on available products. Which account should I open to maximize my savings? Please consider interest rates and potential rewards. Let's send it. Now it's going to take a little bit of time, but in the end it should generate a query. So here recommended me Aldermore Bank fixed rate ISA with a good interest rate. Right, just to show you that it doesn't just randomly generate this sort of stuff and pulls it from a database, I'll show you this exact query that the backend generated, and if you execute it, then this is what it comes up with for Aldermore Bank. And now just to show you all the other banks and interest rates and other products like that, you can see Aldermore Bank is top with rewards, and here are all the other options that it could have gone for. But of course, since we're considering interest rates, it went for Aldermore Bank. Let's ask it another query. Let's say, what is the best savings account? Best savings account, let's say. Yeah, just say that. Probably will ask me, okay. Alright, it provided me similar stuff. Okay, how about best, what can I come up with? Best cash ISA? No, too specific. Best current account for student. Halifax, 0% interest rate. Best current account for student. Okay, fair enough. And let's think another query. Best, let's say top 10 loans, top 10 loan offers. Okay, nationwide, 19 interest rate, fees, including rate fee, withdrawal loan amount, £20,000. Okay, it keeps on going. Right, okay. So these are a couple of generic queries that I asked. Of course, there's loads of stuff to be improved for this agentic system, for this multi-agentic system, but it just gives you a little overview of what it's capable of at the moment. Okay, to finish off, I just want to talk about the challenges that I came across and the lessons I learned and what I'm going to be doing in the future with this project. So the biggest challenge is probably optimizing the agentic system. I'm still quite new in dividing tasks between different agents and then combining it all together. That was something new. It was a good experience to have. So yeah, in the future, I'll definitely want to optimize this. So first of all, make the LLMs give better responses back to the user and back to each other. Divide the tasks, like divide the user task a bit more, break it down a bit more into separating different agents and make everything a bit more efficient. I also want to probably get a better data set, because a dummy data set does work at the moment, but it doesn't. You'll prefer to have a real one, honestly. So I'll probably try to gather a data set. Then last limitation was probably the Grok API limitation. Since the free tier limits how much text I can send over to the LLM at once, sending long conversations over can be quite tricky. So I need to consider that, maybe breaking down or reducing the number of the length of the text that I'm sending to an LLM. So yeah, I think that's about it. Thank you for watching. You can check out the full project in GitHub, try it out yourself, and if you have any feedback or ideas, please reach out to me. Lastly, thank you again for this opportunity. Yeah, that's it.